Let's follow our rules. We know that we can't be. We can't go above 2. We have to go forever left, forever right, forever down, 2 x-intercepts. I think I would draw something like this. Start with forever down and forever to the left. Go up to my boundary. Because I only have 1 x-intercept, I need to come back down and keep going forever to the right and forever down. That would be a perfect graph, I think. Forever left, forever right, forever down. Went up to my boundary, has 2 x-intercepts. You technically could draw other things. The trick here is to make sure you're forever down. You have to have like an arrow going downwards at some point. If you don't, then you haven't followed the rule for range. And the range was y is less than 2. Awesome. Part B. It's going to require a little bit of thinking and a little bit of knowledge from yesterday. It says, explain why it is not possible to draw a graph which has these rules and no x-intercepts. That's the key. Why is it not possible to have no x-intercepts? And I'm going to start with, what do we know about x-intercepts? X-intercepts have y values of 0. So, if you had no x-intercepts, that means you have no y equals 0. Correct? No x-intercepts means no y equals 0. If you look at your range, what does your range tell you? Your range tells you that y can be anything, and has to be anything, less than 2. This says y has to equal 0 at some point. These two things conflict. Not both of them can happen. You only have one or the other. You're going to have your cake and you can't eat it. That phrase never made sense to me. Can't have your cake and eat it too? That doesn't make sense to me. What's the point of having the cake if you can't eat it? And then if you're eating the cake, don't you have the cake? It doesn't make sense. However, with math, when you have 2 conflicting statements like this, not both things are possible, then the whole thing's not possible. Right? You can't possibly follow both these rules. It's not any graph I've ever seen. Awesome. The last example that I do want to do with you is this word problem. Because domain and range with word problems is a little bit different. Also, this is kind of like what we keep building up to in every lesson, right? Is these graphs and these word problems. It says a high school football team is hosting a banquet to celebrate winning the championship. The caterer charges a setup fee of $500 plus $20 per person. The equation right here represents the cost of hosting the banquet for N people. So C is the cost, N is the number of people coming. Make a table of values with 8 entries for a minimum of 100 and a maximum of 500 people. So, we're just going to make a quick table of values. We're only going to do 2. We're going to do a minimum value and a maximum value. So, minimum number of people is 100, maximum number of people is 500. And we're going to input those 2 values to figure out our table of values. Oh, I went too far. Our equation is up here in the yellow. It's C equals 500 plus 20N. But we know that N is actually 100 now. Right? Input 100 in there. When we input it with brackets. We then do any calculations that we can. In fact, this whole thing can be calculated. And I figure that the cost equals $2,500. That's our first input value of 100 people. That's the least number of people who can come. We then need to do an input value for the most number of people that can come. The most number of people that could come was 500 people. So we go back to our equation. We input a value of 500. When we input a value, we use brackets. That's a 500, even though you never know it. I calculate this whole thing. I don't know why my 500 moved so far to the right. And we figure out that the cost is equal to 2,000, 4,000, 6,000, 8,000, 10,500. Oh crap. That was painfully slow. The reason we wanted those two values is so that we could now graph them. Because we now have our minimum point and we now have our maximum point. Okay. We go down here to the grid, it says to draw all 8, we're only going to draw the 2. We're going to make our graph here. These are our x's and y's. This is my y values. These are my x values. I'm going to go up by 100 for my x values, for my inputs. So it starts at 0, and this is 100 right here. This is 200 right here. 300 right here. 400 right there. And 500. Your guys' lines are kind of bolded, right? So it kind of makes sense where I'm going. These are bolded a little bit, those lines. I did every 5. Awesome. For our cost, so going all the way up to the top, we start at 0. We have to get all the way up to about 10,500. So I'm going to count how many blocks I have. 1, 2, 3, 4, 5, 6 blocks. That means I'm going to go up by 2,000s. So this will be 2,000. This will be 4,000. 6,000, 8,000, 10,000, and the highest one would be 12,000. Awesome. We now have our grid. We're going to plot those 2 points that we have. The first point we have was minimum number of people, which would be 100 sales, was $2,500. So $100 here, 2,000 up here, halfway in between would be 3,000. We want to be in between 3,000 and 2,000, so it's right about here. Roughly. The next point that we had was 500 sales. 500 sales got us $10,500. So we make a point of 500, comma, 10,500, which would be somewhere up here. Like that. We plot our 2 points. Realistically, if we were doing this, you should probably do a few more points. You should probably figure out where 200 is, where 300 is, where 400 is, so that you have more points to connect on the line. We're just, for the sake of time, only going to do the 2 points. What I can now do is connect these dots. Okay, I'm going to connect them because I know that every time I make a sale, it's going to go on that line. Oh, that's like money. This represents the trend or the cost of my banquet for my football team. The more sales I have, the more it costs to run the banquet. And it's linear, right? It keeps going up. Every time I get a person, more expensive. Another person, more expensive. Which makes sense because they're eating food, they're making a mess, it's going to be more money. Fantastic. All I want to do with this grid is our domain and range. Okay, that's all. So we can figure that out. On the left-hand side, we'll put it. I think I should be able to put it there. We'll start with domain. We know that domain follows this pattern. Domain is curly bracket x such that. On this question, domain was x. X was number of ticket sales, right? Number of people who were coming to my event. They said there was a minimum sale amount, right? That's why my line stops here and doesn't keep going. Because what was the minimum amount I could sell? They said the minimum I could sell was 100. So I go 100 as my minimum. Then I go less than equal to x, less than or equal to, and in this question, they had a maximum number of sales. Probably because there's a maximum amount I can get into the banquet, right? Otherwise it's too full. What's the maximum number of people I could sell tickets to? 500. All the way up here, which is why my line stopped at that moment. If they didn't have a maximum, then I'd put an arrow on it. We could sell tickets forever, I guess. But realistically, there's going to be a maximum of ticket sales. It's up there. It's at 5. Here's where we're going to get something different. Right? Because this, till now, is pretty much the same with everything else we've been doing. The difference is the XER. XER tells us that it can be any real number in between 100 and 500. Real numbers are decimals. In this question, with this situation, is it possible to have a decimal of a ticket sale? No, you're not going to sell 0.5 of a ticket. You're not going to sell 0.2 of a ticket. Right? So instead of saying x is an element of the reals, you're going to say x is an element of the whole number system with a W. Or from Unit 1, whole numbers are numbers that you can count from 0 upwards. That tells me no decimals allowed. You technically could also put XEI for element of the integers, because integers are counting numbers. You could also put XEN because those are counting numbers as well. The difference between those things is n includes 0, our graph doesn't include 0 anyway, and integers include negatives, which our graph doesn't allow negatives anyway. So that's why XEW is probably the best choice. Awesome. We're going to do the same thing for our range here. We have range y such that the lowest y value, the least amount of money I could make, came from my chart. It was $2,500. Less than or equal to y, less than or equal to the maximum amount of money, came from my chart. It was $10,500. And now we have to again put what type of number are you allowed to have. This one's tricky because you can have decimal values for money, right? Like that's possible to have like 25 cents. Possible. In this question, is it possible? So remember, the cost of your event was going up by $20 every ticket you sold. It was never going up by anything else. It was always going up by 20. So is it then possible to get a decimal knowing you're only going up by 20s? No, you're always going to have a whole number. Y is an element of the wholes. And that would be your domain and range. Awesome. I actually don't like the range value that much. I think that it would actually be a little different. But we're going to leave it like that because it simplifies it. Fantastic. That is domain and range. That's the entire lesson.